Today's lesson is on section 2.5, factoring a polynomial in the form x squared plus bx plus c. So we're looking at a polynomial that has no coefficient in the first term. Now, when we were multiplying, like x plus 2 times x plus 3, we used FOIL. We did first, outside, inside, last. So we got x squared plus 2x plus 3x plus 6. And when we combine like terms, we get x squared plus 5x plus 6. So when we multiplied the 2 times 3, we got that last term 6. And when we added the 2 plus 3, we got the middle term, which was 5x. So that's something important to remember, that we're multiplying the numbers to get the last term, and when we add them, we get the middle term. So we're going to be asked to factor polynomials. So looking at this problem, we'd be asked to factor x squared plus 5x plus 6. So we know the two numbers have to multiply to get 6. So one way to figure this out would be to make a table and put all the things I could multiply to get 6. Well, in this case, there's not a lot of options, 1 and 6 or 2 and 3. And then I find the sum of those two numbers. So 1 plus 6 is 7, 2 plus 3 is 5. So I'm looking for the combination that the factors give me the last number 6, and the sum gives me the middle number 5. So those are the two numbers that are going into my binomial. And those two numbers have to add up to that middle number of 5. So then obviously in this table, the 2 and 3 is my combination. 2 times 3 is 6, 2 plus 3 is 5. So my solution, when I factor that, is x plus 2 times x plus 3. Now at some point you might be asking, well, does it matter which factor comes first? And no, it doesn't. So I could easily say x plus 3 times x plus 2. That's the same thing. Now, as our numbers become larger, making a table is still a way to find the values, but then we're doing a lot of work. So x squared plus 10x plus 24, I want to list all of the possible factors of 24 in my table. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. And those two factors that multiply to get to 24 have to add up to that middle term of 10x. And so that solution would be 4 and 6. 4 times 6 is 24. 4 plus 6 is 10. And so my solution is x plus 4 times x plus 6. But now making this table becomes inefficient, especially for larger numbers because we have so many combinations. So we want to be able to work through this more quickly. So when I have a polynomial I'm asked to factor, for instance, x squared plus 13x plus 36, I know I have two factors. So immediately that's what I want to do, is draw two sets of parentheses, and I know they have to start with x, because I'm going to have the x squared and everything's positive, so I know I have to have a plus in each one. So now I just need two numbers. Now even if I think about things logically, I can see that 36 times 1 isn't going to work, because 36 is already more than 13. So I want something that when I add, I'm going to get 13. Now, sometimes you might try something that doesn't work, so you might try like 3 times 12 and go 3 times 12 is 36. Oh, but wait, 3 plus 12 isn't 13. So if I'm working in pencil, then I can just quickly erase and think, okay, I need two numbers that if I multiply, I get 36, and if I add, I get 13. So that would be 4 and 9. 4 times 9 is 36. 4 plus 9 is 13. So there's my solution. X squared plus 13x plus 36 factored is x plus 4 times x plus 9. All right, try this one. X squared plus 11x plus 28. Okay, pause the presentation, factor that, and then resume. Okay, if you correctly factored this, you were looking for two factors, and everything is positive, so I have x plus x and x plus something. So two numbers that if I multiply, I get 28, and if I add them, I get 11. So that would be 4 and 7. 4 times 7 is 28. 4 plus 7 is 11. So there's my two factors. And again, the order doesn't matter. I could have said x plus 7 times x plus 4. So this is what we want to do instead of making a table, because a table is not efficient. Sure, it gives us all our possible combinations. Eventually, we'll find the right answer. But we should be able to find numbers that we can multiply and add in these different cases. Now, the next case is x squared minus bx plus c. So now we still have a positive at the end, but that middle term is negative. Now, because there is a positive at the end, that means the signs have to be the same. Because a plus times a plus equals a plus, a minus times a minus equals a plus. So the signs have to be the same. But because that middle term is negative, then both our signs will have to be negative. So when we factor this, we're going to have x minus something times x minus something. So for instance, we want to factor x squared minus 11x plus 18. So now, when we factor this, we know we have to have our two sets of factors. Now we've established because the last term is positive, the signs have to be the same. And the middle term is negative, so both signs are going to have to be minus. So it has to be x minus something. And now I just need two numbers that if I multiply, I get 18. And if I add them, I get negative 11. So that's going to be 2 and 9. Negative 2 times negative 9 is positive 18. Negative 2 plus negative 9 is negative 11. So there's my two factors. Okay, here's one for you to try. X squared minus 8x plus 15. Pause, factor that, and then resume. Okay, two numbers that multiply to get 15 and add to get 8 are 3 and 5. So my solution is x minus 5 times x minus 3. Now try this one, x squared minus 13x plus 42. Pause the presentation, factor that, and then resume. All right, two numbers that multiply to get to 42 and add to get to 13 are 6 and 7. So x minus 6 times x minus 7. Now, the next possibility is that the end term is negative. If that's negative, then the signs have to be different because a positive times a negative gives me a negative. And so the middle term can be either positive or negative, doesn't matter. If the last term is negative, then the signs have to be different. So I'm going to have one is a minus and one is a plus, x minus something and x plus something. So here's x squared plus 5x minus 6. So I know my two signs have to be different. So I have to have x plus something and x minus something. So because the signs are different, in this case, the difference of the numbers has to give me the middle term, not the sum of the numbers, because the signs are different. Now, if I put 1 and 6, 1 minus 6 isn't going to give me a positive 5. Okay, the difference is 5, but the difference is negative 5. So x plus 6 times x minus 1 is our solution. Positive 6 times negative 1 is the negative 6. Positive 6 minus 1 is the 5. Now, if I had x squared minus 5x minus 6, that's very similar to this other polynomial, except now the 5 is negative. So again, because the last term is negative, I have to have a positive and a negative. So I have to have x plus something and x minus something. So the two numbers have to multiply to get 6 and add to get negative 5, where the difference of the numbers without the signs is 5. So again, that's 6 and 1, but this time the 6 is the negative value. Okay, the higher number has to be negative to get the middle term negative. So when the sign at the end is negative, the terms are positive and negative. And then the difference of the term gives me the middle. And the bigger term has to have the sign of that middle term. All right, here's one for you to try. X squared minus 5x minus 14. Factor that polynomial. Pause the presentation, factor, and then resume. X minus 7 times x plus 2 is that polynomial factored. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. All right, factor x squared plus 6x minus 16. Pause the presentation, factor that, and then resume. Okay, two numbers that I can multiply to get 16 and subtract to get 6 are 8 and 2. And the bigger number has to be positive because we have a positive in the middle. So because that was a positive 6, the bigger number had to be positive. And the one before it, because the middle term was negative, the bigger number had to be negative. All right, lastly, what if we have two variables? So we have x squared plus 10xy plus 24y squared. Well, the process is really no different. We're going to factor that, so we know we have two binomials. We have the x squared at the beginning, so we know we have to have an x at the beginning, and we have y squared at the end. So the last two terms then have to have a y, so y times y will give us the y squared. And we have all positive values, so we know everything has to be positive. And now we're just back to doing what we did before. Two numbers that if I multiply, I get 24, and if I add them, I get 10. What are those two numbers? Well, hopefully you said 4 and 6. 4 times 6 is 24, 4 plus 6 is 10. So x plus 4y times x plus 6y gives me x squared plus 10xy plus 24y squared. Okay, here's one for you to try. Pause the presentation, factor this polynomial, and then resume. Okay, just like before, we have an x and a y. We need two numbers that if I multiply, I get 32, and if I add, I get 12. So I have x plus 4y times x plus 8y. Okay, 4 times 8 is 32. 4 plus 8 is 12. All right, try this one. Pause the presentation, factor that polynomial, and then resume. Now in this one, we have that plus at the end, so the signs have to be the same, but we have a minus in the middle, so the signs have to both be negative. So now we're looking for two numbers that when we multiply, we get 21, and when we add, we get 10. So x minus 3b, x minus 7b. 3 times 7 is 21, 3 plus 7 is 10. Last problem, p squared minus 5pq minus 36q squared. Pause the presentation, factor that polynomial, and then resume. All right, this time the last term was negative, so the signs had to be different. We needed one positive and one negative. Because the middle term is negative, the bigger number has to be negative. So we needed two numbers that when we multiplied, we got 36, but when we found the difference of the numbers, we got 5. And the bigger number had to be negative. So p minus 9q times p plus 4q. Now again, the order didn't matter. So we could have put p plus 4q times p minus 9q. That's also the correct answer. Now the order matters, but the signs also matter. So we could not put 4 or p minus 4q times p plus 9q because 9 minus 4 is a positive 5. So this is not correct. So we've got to make sure we get the signs correct. Okay, that's our presentation on 2.5. So now let's do the classwork. Woohoo!